Hello, I am Riyanka Chakraborty. In my previous video, I was discussing about the half-wave rectifier. So today, I will discuss about the full-wave rectifier. So we know that there are two types of rectifier, full-wave rectifier. One is center-tap full-wave rectifier, another is bridge rectifier. So first of all, I will discuss about the center-tap full-wave rectifier. So why it is called center-tap? Because here we use a center tap transformer. Actually, center tap transformer is nothing but a normal transformer with one slight modification. It has an addition wire connected to the exact center of the secondary winding. This type of construction divides the AC voltage into two equal and opposite voltages, namely positive voltage, that is VA, and negative voltage, that is VB. Here we see that this one is VA and this one is VB. So the total output voltage is V equal to VA plus VB. So this is the definition of center tap transformer. So in center tap full wave rectifier, we use this type of transformer. That's why it is named as center tap full wave rectifier. So this is the circuit diagram of center tap full wave rectifier. Actually, in full wave rectification, current flows through the load in the same direction for both half cycles of input AC voltage. This can be achieved with two diodes working alternatively. For the positive half cycle of input voltage, one diode supplies current to the load, and for the negative half cycle, the other diode does so. Current being always in the same direction through the load. Therefore, a full wave rectifiers utilizes both half cycle of input AC voltage to produce the DC output. So, in center tap full wave rectifier, the circuit employs two diodes D1 and D2. A center tap secondary winding AB is used with two diodes connected so that each uses one half cycle of input AC voltage. In the other words, diode D1 utilizes the AC voltage appearing across the upper half of secondary winding for rectification, while diode D2 uses the lower half winding. So, during the positive half cycle of secondary voltage, the end A of the secondary winding become positive and NB become negative. This makes the diode D1 forward biased and diode D2 reverse biased. Therefore, diode D1 conducts while diode D2 does not. The conventional current flow is through the diode D1, load resistance RL, and the upper half of the secondary winding, as shown by the arrows. This one, like this. During the negative half cycle, end A of the secondary winding becomes negative and end B becomes positive, while diode that means the diode D2 conducts, while diode D1 does not conduct. The conventional current flow is through diode D2, load resistance RL, and lower half winding, which is shown by these arrows, like this one. It may be seen that current in the load RL is in the same direction for both half cycles of input AC voltage. Therefore, DC is obtained across the load RL. So we get this type of output signal, that is the DC signal output. We apply this input AC signal and we get output DC signal. Okay. So this is the waveform of full wave rectifier. This is the input signal. For the positive half cycle, we get this output, and for the negative half cycle, we get this one. While in case of half wave rectifier, we saw that in case of negative half cycle, we do not get any type of outputs. We get only for outputs only for the positive half cycle. But here we get the output for the negative half cycle also. So now we merge these two and we get the total output like this. Okay. So now the full wave bridge rectifier. So this is the circuit diagram for bridge rectifier. It contains 4 diodes actually, D1, D2, D3 and D4 that is connected to form a bridge. That's why it is called bridge rectifier. The supply to be rectified is applied to the diagonally opposite ends of the bridge through the transformer. Between other two ends of the bridge, the load resistance RL is connected. Okay. So during the positive half cycle of the secondary voltage, if just a minute, if I write this one is P and this is Q. So during the positive half cycle of the secondary voltage, the end P of the secondary winding becomes positive and end Q, this one is positive now and end Q is negative. This makes diode D1 and D2 forward biased while diode D3 and D4 are reverse biased. Therefore, only diode D1 and D2 conduct. These two diodes will be in series through the load RL. The conventional current flow, which is shown by these arrows like this. So, if it is A and if it is B, the conventional current which is flows from A to B through load RL. Okay. Now, during the negative half cycle, again it is P and it is Q. Now, for the negative half cycle, I think P is negative and Q becomes positive. So, this makes diode D3 and D4 in the forward biased and D1 and D2 in reverse biased. Therefore, only diode D3 and D4 conducts. These two diodes will be in series through the load RL. The current flow is shown by these arrows. So it may be seen that again current flows from A to B through the load resistance RL in the same direction as for the positive half cycle. Therefore, DC output is obtained across the load RL. Okay, so this is the working principle of bridge rectifier. So this is the waveform of bridge rectifier. Like the center tap full wave rectifier, the waveform is same. So that's all for today. If you like my video, then please like and subscribe my channel. So if you have any questions, please drop it in the comment box. So thank you and goodbye. Stay safe.